Hey YouTube, it's Yaki, and today I'm going to show you how to draw a Unit-Circle-o-Tron. You'll be able to cut this out, put it in your notes, use it on tests. I know these Thale burgers are early and Pi Day isn't for another few weeks, but I'm feeling it already. But before we get carried away drawing triangles inside of our unit circle, I first want to draw a circle inside of our unit triangle. You may have noticed a lot of videos on the internet lately of people trying to square a circle. The difficulty lies in that the diagonal is not equal to 1, it's equal to the square root of 2, which is about 1.4, but it is a long and irrational number, which depends on the number of bits in your calculator. Vsauce's approach was to draw two circles inside of a unit right triangle. This is much harder to draw than a simple proof for, let's say, the golden ratio, which can be found on our channel banner and end screen. The easiest proof for squaring a circle to me is Thale's theorem, because even if you don't draw it exactly measured correctly, you can still see how the shaded area of the circle is equal to the shaded area of the square. If we cut out our circle, we can roll it and trace it as well. So while finding 4 infinitesimal points on a circle in order to square a circle is not that mind-boggling, cubing a sphere is just too much for me to explain right now. The square root of 2 is an irrational number, like phi, but why is it that phi can generate all of these properties of the sine function? I like to use music as an approach to number theory. We can generate a fib sequence, finite sequence of an irrational sequence to draw TIE fighters and fly those TIE fighters in Telnet. Okay. Back to the video. Next, draw all the overtones on one standing wave. We can copy and paste these overtones, rotate them 5 degrees, and get a phi fan. Once we have labeled our circle-o-tron so we can rederive the unit circle later, we can now use our circle-o-tron and reimpose it on the original unit circle to derive sine and cosine functions. We can also generate these functions in our TI-82 and superimpose them.